Well, I think what we expect is that this discussion will continue. I think that the tension between China and the US, we've said it a few times, is most really there to stay. That we expect. In which form this may come, we don't know, to be honest. I think there's been a major change in the US administration. We still have to see, I would say, how they will address this challenge. So I don't think we expect anything. I think today we don't know. But we are very much engaged, of course, with the different governments, so to make sure that, we can be part of that discussion when this discussion will happen. Well, I think, China has been very strong in 2023, 2024. That created a lot of question on the exact size of China.
While ASML executives in the Netherlands remain locked in heated debates about whether to continue exporting lithography machines to China, a technological earthquake is reshaping the semiconductor landscape. China's domestically produced LPD EUV lithography machines have successfully completed trial production of 7-nanometer chips. This represents far more than just another industrial advancement. It's a technological revolution with profound implications for national sovereignty and global technological balance. The successful development of this machine signifies that China has finally torn through the iron curtain that Western powers constructed around cutting-edge chip manufacturing. Traditional EUV lithography machines require generating light at an extraordinarily precise 13.5 nanometer wavelength to carve microscopic circuit patterns onto silicon wafers. To appreciate the technical challenge involved, imagine attempting to engrave the entire scroll of Along the River during the Qingming Festival onto a single human hair. ASML's industry-standard EUV systems cost over $150 million each, containing more than 100,000 precision-engineered parts. Only 3 countries worldwide can produce the most critical components, creating a bottleneck that has been weaponized through export controls. The technological path China has chosen, LPD or laser-induced discharge plasma, represents a fundamentally different approach to generating extreme ultraviolet light. Rather than following ASML's methodology, Chinese engineers have pioneered a system that reduces energy consumption by an estimated 80% compared to conventional approaches. While ASML relies on high-powered lasers to bombard tin droplets, China's LPD approach shrinks the equipment footprint by approximately 1/3 while reducing manufacturing costs by a remarkable 4/5. This strategic innovation has enabled Chinese manufacturers to construct a functional 7-nanometer capable lithography machine for approximately 280 million yuan, roughly $40 million. While these first-generation domestic machines cannot yet mass-produce chips at the bleeding-edge 3-nanometer node, they provide more than sufficient capability to satisfy an estimated 80% of industrial requirements, including critical applications in new energy vehicles, Internet of Things devices, and industrial automation systems. The breakthrough in LPD EUV technology required simultaneous innovations across 4 core technological domains. A specialized research team from Harbin Institute of Technology developed a revolutionary method using high-voltage discharge vaporization of tin to replace traditional laser bombardment. This approach reduces the required light source power from 250 watts down to 50 watts, while increasing operational stability by 3-fold. This innovation directly addresses one of the most persistent challenges in EUV lithography: the tendency of extreme ultraviolet light to attenuate rapidly. Researchers at the Changchun Institute of Optics and Fine Mechanics made equally impressive advances in optical systems. Their newly developed silicon carbide lenses exhibit a thermal expansion coefficient 90% lower than conventional quartz glass alternative. These lenses maintain extraordinary precision, with accuracy error remaining below 0.1 nanometers, even after continuous operation for 10 hours. To visualize this level of stability, imagine balancing a coin perfectly on the summit of Mount Everest through hurricane-force wind. Quantum sensors continuously calibrate the optical pathway in real time, while sophisticated AI algorithms predict even the most minute workshop temperature fluctuations. These systems work in concert to achieve overlay accuracy of 3 nanometers, approximately 20% superior to comparable ASML equipment. This precision is particularly critical for multi-layer semiconductor manufacturing, where misalignment of even a few atoms can render an entire chip useless. Researchers at the Chinese Academy of Sciences have developed a groundbreaking super LTI mask technology that utilizes advanced two-dimensional material stacking techniques to generate patterns at the 0.1 nanometer level. This innovation effectively circumvents the multi-layer mirror silicon film technology that Western companies have jealously guarded for decades. China's semiconductor industry isn't merely developing isolated technologies, it's constructing an entirely new ecosystem. Shanghai Microelectronics has emerged as the system integrator for complete lithography machines, while the Chinese Academy of Sciences provides advanced testing equipment, and Northart contributes cutting-edge etching systems. Together, these organizations form what industry insiders call the Iron Triangle of China's semiconductor independence. The localization rate for critical semiconductor manufacturing components has skyrocketed from a mere 7% in 2018 to an impressive 42% today. Complementary advances across the semiconductor supply chain are accelerating this transformation. Zizhou Xinhua 12-inch silicon wafers have achieved extraordinary purity levels of 99.9%, a critical requirement for advanced chip manufacturing. Meanwhile, the Nanjing University of Science and Technology has successfully developed photoresist materials capable of 5-nanometer process nodes, directly challenging Japan's JSR Corporation, which has seen its market share plummet by 15% over just 3 years. Perhaps the most disruptive innovation comes from Semiconductor Manufacturing International Corporation, which has pioneered a nano-imprint lithography process that enables 28-nanometer equipment to produce 5-nanometer chips, while reducing energy consumption by 40%. This remarkable combination of seemingly outdated equipment paired with cutting-edge process technology has left many Western semiconductor engineers bewildered. As one TSMC engineer candidly admitted, "I simply don't understand how they're achieving these results with that equipment." The market impact of these developments has been swift and dramatic. ASML's most recent financial reports reveal that in the first quarter of 2025, China's share of the company's revenue plummeted from 42% to just 18%. Triggering a market capitalization decline of approximately 32 billion euros. In response, the Dutch government has hurriedly approved the export of 1,980D EUV lithography machines to China and established a maintenance center in Shanghai in an attempt to recapture lost market share. The United States has likewise made policy adjustments in response to China's unexpected technological leap. The Department of Commerce has removed nano-imprint equipment from its entity list restrictions and has permitted Applied Materials to resume cooperation with SMIC. These policy reversals reflect a recognition that China's annual $450 billion semiconductor import market is undergoing fundamental restructuring, with domestic alternatives increasingly replacing foreign technologies. Looking back at the historical record, Western media outlets have consistently issued prophecies of China's technological limitations, from claims that Chinese chip technology had no hope of catching up within 10 years, to predictions of Huawei's complete withdrawal from the 5G market. Each of these catastrophic forecasts has been systematically falsified by subsequent developments. Market data provides compelling evidence for this perspective. China's semiconductor equipment procurement has grown by an impressive 37%, despite global economic headwinds and targeted sanctions. Chinese manufacturers now account for approximately 40% of global production capacity for mature 28-nanometer process nodes, technologies that remain essential for a wide range of industrial and consumer applications. As legendary semiconductor pioneer Morris Chang once observed, "There are no eternal industry leaders, only innovators who never cease pushing boundaries." The ultimate victors in this technological competition will not be determined by nationality or historical dominance, but by commitment to open innovation and collaborative advancement even amid geopolitical turbulence.